All right, so here we are at 1.5. Hello, everyone. 1.5 Foundations of Mathematics 12. Here's your textbook by Nelson Education. And we are looking at section 1.5 and 1.6 today. So here's the lesson for 1.5. It's entitled Investments Involving Regular Payments. This is what it looks like in your textbook here. Investments involving regular payments. And of course, this is on page 46 if you're following along. All right, so we are going to be using a financial application online. Some of you may have a TI-83 graphing calculator with the finance application on that, and I'm going to show you how to use that one too. But if you don't, we'll be able to use an online application. Okay, so investments involving payments. Now, in 1.4, if you remember, I'll go back to 1.4. Whoops, that's not 1.4. There's the text. In 1.4, what we were learning about was compound interest. We learned in 1.3 about future value. Now we rearrange things in 1.4 to talk about present value. But all these things that we're learning about in 1.1, 2, and 3 is like a lump sum, and there's interest being calculated from that lump sum. Okay, so just one input, and then we'll find out what the interest is there. Well, what we have here in 1.5, go back to 1.5. is throughout this process, you are adding payments every month or every year or whatever it is. And so that adjusts the growth, right, of this investment. Or if you took a loan out, right, obviously, when you take a loan out for a car or something like that, you're going to be paying it off every month. So there's interest being calculated on what you owe, but you are knocking that value down a little bit every month to get down to zero. You're not waiting for 5 years and then saying, okay, I'm going to pay one big lump sum with all of the interest that's accumulated. I'm going to pay it off. No, you pay off a little bit every month. So this is a more realistic, real life sort of look. Now, I've got a couple diagrams here. Okay. So if we were investing, so let's say that we have a lump sum right here, this principal. And in compound interest, I am going to put that lump sum in. I'm not going to touch it, do anything with it for years and years and years, and it's going to grow something like this. Okay, so that would be maybe a graph for compound interest, right? Well, with payments, okay. So if we look at case 2, okay, with payments, with regular payments, the graph might look something like this. Let me zoom in. So this is not going to be excellent, computer graphics or anything. But watch this. Let's say I make payments at these regular intervals. Okay? So what's going to happen is I'm going to make, put a little bit of money in. I'm going to let that grow for this first little period. Then what you're going to do is you're going to add another payment to the pile. And so your principal just boom goes up like that. Okay? And so now you've got a little bit more money that's gaining a bit of interest. Okay? Not much is going to change until your second payment. Oh, then you have another little boost. And so what happens is now you have more money, and so this part of the graph right here is going to grow a little bit faster than this part. Okay, well then you get to, oh, that's not very smooth, but let's say you get to this part. Oh, another little bump, another payment. Oh, then it grows really fast, another payment. Look at that. So you end up, okay, another payment and so on. So you end up, it grows super fast, okay? And so you're giving a little bump every time. Okay, and over here, let's say you're taking a loan out. And you're paying off the loan. Okay, well, okay, paying off the loan. Well, let's say you have you took out a loan for a car right here. Okay, and it's growing. You know what? The interest is accumulating, and you know what? If you don't touch this, if you pay it off here, this is your future value right here. Here's your future value right here. This is what it turns into, okay? Here's your initial amount. There's what it turns into. You owe all this interest. But in the case 2 for a loan, okay, you're making payments again, okay? And what happens is, yes, you've got this that you've borrowed, and it grows a little bit. But then what? You knock it down, okay? You knock a little bit down. You don't take it right off, because I'm exaggerating maybe a little bit. But then watch. Okay, it's going to grow in between periods. Yeah, but then you knock it down a bit. Okay, so it's going to grow, knock it down. It's going to grow, knock it down. Okay, you keep knocking it down. And so what happens is, right, you end up owing this much at the end, because you kept kind of knocking down the principal there. Okay, hopefully that makes sense. I don't know, that makes sense to me anyways. You know, those graphs are pretty amazing, I'm gonna say. Who needs computer graphics when you can draw like that? But anyways, so yeah, I did this down here too. So you know, if this is the growth right here of the blue, so you take a loan right here, you take a loan, and then it just keeps growing. And if you're making payments, the loan kind of grows like this. It doesn't grow as fast, right? Because you keep knocking it down. All right. So how are we going to do this? Well, we are going to use something called a TVM Solver. Okay. So let me just show you where that is on your graphing calculator. Let's say you have a graphing calculator at home, or you're watching this video sometime and you do have a TI-83, and it's got an application button, and on that applications you've got the finance. Okay, that's the function you're going to want to use, finance. When you hit that, you come up to this next screen over here, and this screen shows, number one, a TVM solver. See that? When you click enter into that function, you get over into this screen, and this is where you're going to want to live here for these solving these questions. Okay, so the calculator is going to do a lot of work for us. If you don't have a graphing calculator, then I'm going to invite you to go to this screen right here, and so whoops, here's what it looks like. Financial calculator. It's fncalculator.com, and if we want to go to mrmathwell.com, well, here's a shameless plug again. TVM Solver online. That's what you get. That's where you go, right here. So if you want to do this with us with this TVM Solver online, just click this link and it will take you to here. Actually, it might take you to just this page right here, TVM Calculator. I don't know if I've adjusted that yet. You're going to want to go to the advanced version, okay? And this is going to be real slick. This is going to be easy. Now, why do we need the calculator to do this? Why can't we just do this by hand? Why can't we just use, you know, A, future value equals P times, you know, why can't we just use the equation? Let me just show you, and you'll be able to see this on page 47 in your text, okay? Let's go back to the notes. Okay, check this out. Here's example 1, okay? And the quick rundown of this question, I'm going to come back to this question. We're going to use that TVM solver, but here's example 1, okay? Darva is saving up for a trip to Australia in 5 years. She plans to work on a student visa while she's there. So she needs only enough money for a return flight and her expenses until she finds a job. So she deposits $500 into her savings account at the end of each 6-month period from what she earns as a server. The account earns 3.8% compounded semi-annually. How much money will there be in the account at the end of 5 years? So this is an example where she's putting money away, and the money that she has in there is growing interest. When she adds to that, there's more principal that grows interest. She's going to add to it some more. It's going to grow a little bit more. So look at how you would have to tackle this without the graphing calculator or without the financial applications, which you can totally do it. But I'm just going to show you what you would have to do, because we're just going to work with the online calculator. Okay, as long as you can get that figured out and understand what it's doing, that's the important thing. So here we go. 6 months, she's got $500. Okay. Now this particular payment of $500, this one alone is going to be accumulating interest for 9 periods. If we're talking about 5 years, there's 10 total periods. So this one is acted upon for nine periods if you count this all up. The second $500, the $500 she puts in at the year mark, that's going to be 500 times her interest rate, 1 plus her interest rate to the power of 8. So it's going to get compounded 8 times. The next one is going to get compounded 7 times, and so on, until the very last one at the very 5-year mark is going to get compounded 0 times. It's just $500 she puts in there at the very end. So what you'd have to do is you'd have to find out each one of these, what the value of each one of these would be, and add them all up. Okay? So that's okay. That's totally fine. You could do that. That's going to take some time, though. You got to do this, you know, you're going to have to do this 9 times or whatever, 10 times. So, okay, that's the idea. So now what we're going to do is we're going to use this advanced calculator. So I'll get you to join me online here. TVM Advanced Calculator, okay? The mode is default at the end. Now what this means, end or beginning, this is at the end of every compounding period where the payment is made, or at the beginning of every compounding period where the payment is made. Different questions call for different things. Most of the time it's at the end though, so that's the default. Okay. So for this particular question, and you've got it on page 47 there. So she plans to work on a student visa, blah, she only needs, okay. She deposits $500 into her savings account. Now, payments, here's where you put the payments. But let me just inform you about something, okay? If you are making a payment like you are giving money away, okay, that's like money going out. That's usually represented by a negative sign. So we're gonna put negative 500 there, okay? It's money that you're giving away. You're putting it away. The future value then will be positive. That's the money that you're gonna get back out, okay? Positive. Now, if you forget that and you just put positive 500, no big deal. That means the future value will then be negative, but you understand that it's, you know, you don't have to pay that, whatever. So paying what you pay is negative, okay? All right, so we don't know the future value. That's something we're gonna have to find. But what else do we know? So how can we fill this in? The present value is 0, okay? If you started with, let's say your parents gave you some money at the beginning, you know, $700, well then you could start with 700, and then your payments of 500 would add on to that, and so on. So the present value here is Zippo, okay? Now the payment frequency, she's gonna make this payment frequency, okay? So the periods here, okay, we're gonna go, the periods are going to be semi-annually, two times a year it says in the question, okay? And the interest rate, I guess we could do that. That's 3.8, correct? 3.8. The periods, okay, so how many periods? We're talking about 10 periods, 5 years semi-annually, that's 5 years times 2 per year. So the periods are 10, okay? And the compounding periods, so the compounding frequency is semi-annually as well, semi-annually. All right. So I think we should have something that looks like this. I'm going to go back to my notes. I did fill this out over here. So here we go. Okay. So this should look the same as what we have online right here, the top one. Okay. So when you get to this, you're going to leave future value blank. Okay. And then what you're going to do is you're going to push the future value button, and it should show up with this number right here. So let's give that a try. And we've got everything in there correct. I'm going to hit future value. Look at that. $5,449.90. So that is the future value of this in this question. Okay? And that's just using the graphing, the technology there. Okay? So what was that? That was, so that was all this added up. Okay? What you would normally have to do, the calculator did all that for us. 5,449.90. Okay? All right. Now, what does it say? Does it say the actual question, how much money will be in the account? How much of this money will be earned interest? Okay, well, so this kind of question right here, how much money would be in the account? That's the 5,449.90. How much of this is interest? Okay. Well, what did she put in? What's the raw bottom line? What did she put in? Well, she put in, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So she put in 10 times 500, which is $5,000. So compared to what's in there now, the interest would be the difference between those two. So the interest is 449.90. Get it? So that's the interest, and here's the first answer, the total amount that's in there. All right. So let me know if you have any questions. Okay, so the question here was, what does it look like on the TI-83? Perfect. Let's do that real quick here, and if you don't need this, you can fast forward through this part, I guess, if you're watching the video. But what you're going to hit is the apps, and you're going to hit enter, and you're going to hit enter again. You're going to get to this screen, okay? So just like we did, and I will actually kind of go over to what we did over here. So just like we put in, so n is the number of periods involved. So we're talking about there's 5 years with 2 periods per year, so n is going to be 10. Okay, you're going to hit that. Whoops, hit enter. The percentage of interest, so the interest is 3.8. That's always the annual interest there. Okay, present value 0. Okay, so you just hit enter there. The payment. Now we don't know what the payment is, so just leave that for now. Okay, we're going to come back. I'll show you how to figure that out. Or sorry, payment we do know, it's future value. So I'm going to do negative 500 here. Okay, the negative, the negative, positive, all that still holds true. Future value we don't know. Now this P/Y, oh come now. The P/Y. Okay, something is. Give me a second here. All right, my computer froze up a little bit there. So this P/Y is payments per year. Payments. So P for payments. Okay, payments per year. That's 2 times per year. So that's a 2 right there. 2. And this C/Y is compounding periods per year. Okay, so the number of compounding periods per year, and this is semi-annually as well. So we have to put 2 there. Now it'll automatically do the same as the payment periods unless you change it. Okay, so now we've got everything input that we need, and this is how you calculate. Okay, you go up to, you go to future value. That's what you want to calculate, and then there's a little solve button on the enter. So you got to go alpha, enter, and it will solve for you. And you can see now that here's the future value, exactly the same as what we got online. 5449.90, so 5449.896, you'd round that to 90. Okay? Okay, so the next example is in the textbook as well, and I've got it just recopied out here. So example 2, we'll take a look at example 2. So Adam made a $200 payment at the end of each year into an investment that earned 5% compounded annually. So we've got a lot of information there. The $200 payment at the end of each year, 5% interest, compounded annually. That's great. Blake made a single investment. Okay, I'll use blue for Blake stuff here. A single investment at 5% compounded annually. So that's just a lump sum, a one-time payment. He just put it in the bank and let the interest accumulate. No regular payments. At the end of 5 years, their future values were equal. Okay. At the end of 5 years, their future values were equal. What was their future value? So we're going to have to figure that out. What principal amount did Blake invest 5 years ago, and who earned more interest? Why? So let's take a look at Adam. Okay. So we'll go back to online here, and I'm going to try and move that over. Where's my notes here? Okay, I'll put that over to the other side. So let's take a look at Adam first. Adam had a $200 payment. So payments are going to be here, $200, $200 payments. His present value was 0. He had nothing in there before that. Okay, we don't know what this is, so I'm just going to back that off here. His percent interest was 5. Compounded annually. Perfect. The number of periods. Okay, well, what are the number of periods in this question? Well, we said 5 years, right? And he paid at the end of each year. So periods for him are just going to be 5, and those are paid annually. Okay. The compounding period is also annually. So I'm going to change the compounding to annually there. All right. So we have nothing to start with. We have payments of $200. Those payments are every year for 5 years. 5 payments annually. Okay. The annual rate is 5%, and that is an annual, and it's compounded annually. Okay. So I think I'm going to have to go here and press this button, future value. And it looks like I've got 1105 for a future value. Okay, 1105. All right, hopefully everybody sees that. So we have enough information to find out what Adam is going to come away with at the end of the 5 years. So that's 11,0513. Now the question says that they end up, their future values are equal. See that? So that means that Blake ended up with that much as well. So what we're going to do is we're now going to find out what Blake put in. So we need to solve what his present value was. So watch this. I'm going to leave that future value there. The payments are 0. He didn't make any payments. What was his interest rate? Okay, it was 5% as well, compounded annually. So 5% annually. All right. There's periods, there's 5 years periods. Now the payments, annual payments of 0, it doesn't really matter, does it, if it's annual or monthly or whatever. So this really is only for the payments, okay? Compounded annually, that looks good too. So right now it looks like we have enough to find out what Blake's original amount was. So let's see if we can do that. So present value, I want to find out what the present value is, and 865.90. Okay, so yeah, Blake's investment, his present value was 865.90. Okay, so we gave the calculator the future value. We told it all of the interest rate and everything like that. No payments. Go back now and find the present value. So 865.90. 865.90. Who earned more interest and why? Okay. Well, so Adam made $200 payments every year for 5 years. So guess what?
Whenever I put in the...
Okay, so Adam, he had $200 at the end of each year. So 200 times, I guess, 5 years, right? So that's $1,000 he put in, and he made 11,0513. So his interest was 105.13. And Blake over here, okay, his original input was 865.90. Right, that's how much he put in, and his future value was 11,0513. 11,0513. Okay, and so we'll subtract those two things. I'll do that real quick. 11. Oops, on 11. Oops, clear. Quit. 11,05.13 minus 865.90 and 239.23. 239.23. So for C, who earned more interest? Well, it looks like Blake did. Okay. Now, why? Well, what you want to look at here is you want to look at Blake had this much money in for a full 5 years. Right? For the first year, Adam had no money in. 0. Because he didn't make a payment till the end of the first year. So on his second year of earning interest, he only had $200 in there. So all this time is going by, and there's not a lot of money in there for this interest to be acting upon. So yeah, Adam, he's making 200 payments at the end of every year, so that's great. But if you're able to come up with a little bit more at the beginning, you let time do all the work for you. See? Time does the work for you if you can put some money in at the beginning. So yeah, so Blake ended up earning quite a bit more. Okay, so that's example 2. There's the calculator. There's our TVM Advanced Calculator online. Anybody else have any questions? All right, there's your 1.5 lesson.